Our next topic concentrates on SDG12 and SDG9, sustainable manufacturing, converged sustainability and asset-controlled multi-sensor digital twin for Industry 4.0 and 4.5.0, covered by Mr. Narayanan Subramaniam, Chief Technology Officer, Eugenie.AI, India. Having more than 28 years of experience of technology leadership experience, which spans the IoT, electric vehicles, SaaS, AI/ML, data center, and telecom networking domains. He has graduated with a BTech in Electronics and Communication Engineering from the Indian Institute of Technology, Madras, and an MS in Electrical Engineering, from the University of Maryland at College Park, USA. He holds 10 US patents. As a Chief Technology Officer at Eugenie.AI, Narayan's mission is to leverage AI-based solutions that enable humanity to thrive sustainability.
Thank you so much, Sagarika. I hope my audio is okay.
It's fine. You can go ahead. Thank you.
All right. Thank you so much for the kind introduction, and really honored to be here as part of this esteemed gathering. And of course, a very good evening, good morning, good afternoon to all the wonderful participants. Thank you for taking the time to be here. And I'll just share some thoughts around that topic. So let me just share my screen. Good. Let me just jump into the topic right away, right? So, I think we have got very used in the last 2 years or so to see various curves of various forms, right? Especially when it comes to the pandemic, flattening the COVID curve, flattening the infection curve, right? Well, we have a very big curve to flatten or to take care of, if you really look at it, and that is the emissions curve. It's just represented in some form here by our gigatons of carbon dioxide that we emit and so on, right? But what this curve is really trying to tell us is a story. The longer we delay, the emissions reduction, the longer we delay our actions in actually moving to renewable technologies, but even before that, to control the emissions curve, the harder and harder it is going to get for us to meet, the goals for 1.5. Now it is 2.5, and who knows what it's going to be, at the turn of, by the time we reach 2100, right? The expected emission cuts required are just going to become steeper and steeper the longer we delay. It's common sense. Although it's common sense, unfortunately, we as a global community have not done enough over the last 30 to 40 years of ample warnings to take a serious note of it. And that's why we are in this, crisis today, right? Now, what does this mean and how do I connect it to the work that myself and my team do, right? Although we talk about 1.5, 2 degrees, 4 degrees, and so on, all is not well, even at 1.5 degrees warming by the end of the century, right? There are varying range of estimates with respect to loss of biodiversity, species loss, ecological devastation, and so on. If you go to 2 degrees, and what's the big deal about 2? It's only 0.5 more than 1.5, right? Well, the impact is not linear. It starts becoming exponential, right? You go to 3, you go to 4.5 degrees, and by all trends, the way that we are heading is probably upwards of 2 to 3 to 4, right? Given our current habits. The numbers are extremely scary, and it doesn't paint a pretty picture at all with respect to the loss of plant and animal species that we are going to experience, right? Now, why is how do I connect this to what work my team does and what I think needs to happen across industry, right? Is the fact that so when some of us looked at this problem, we dropped our regular jobs as technologists in the high-tech industry and across the board. And many of us who really felt passionate about, we really have to take some action on controlling this emissions curve and preserving biodiversity on this planet. Otherwise, what's the point, right? And that's what led us to attempting to deliver a solution that makes use of, that takes care of existing industries, right? Now, whether we like it or not, oil and gas is here. It powers most of the world. All the stuff, all the buildings that we live in are built using steel, cement. Mining is an integral part of our economic life and activity that we can't throw away, right? We also acknowledge, right, that these are probably half of the industrial global greenhouse gas emitters, right? It's easy to paint, folks in these industries in a corner, but this is what runs our economic systems and societies as we humans have defined it, right? Which we cannot turn over overnight, right? So we have the current way in which we run our economies and societies, which obviously needs to change. We have the problem of we have to flatten this emissions curve of carbon dioxide and methane. And we have to do it now. So that's what led us to develop the technologies that we are working on at Eugenie.AI. Is while there is lots of wonderful companies focused on solar, wind, hybrid, geothermal power, electric vehicles, which I was also a part of in my past, right? The world cannot wait for the entire transition to happen. How do we clamp down that curve right now, right? And so that's why we focus on developing technologies on the heavy emitters and putting them in practice so that in real time, okay, using our sophisticated, AI-based algorithms, we are able to maintain their business productivity while pressing the emission curve down, right? And that this is technology that we are now deploying, in pilots in various places and industries, across the world, right? And this is what we are really focused on. How do we reduce it now, right? Because unless we reduce it now, 1.5 and 2 or 2.5 is not achievable. Even if the whole world moves to green in 10 years, we are too late, right? So that's what we are really focused on. Now, there is a lot of economics that gets talked about, with respect to, the world needs to completely change its asset base. You're looking at, trillions and trillions of dollars worth of investments needed, right, to replace existing legacy equipment and replace them with cleaner technologies, with more efficient technologies, right, with perhaps renewables as its focus. But this is going to take time. It is going to take a lot of money. As you are seeing in COP27, there is so much of debate about financing, right? And, we can keep talking about financing and economics forever, but nature and the planet is not going to wait, right, in terms of the consequences. So we got to act now, and we are designing technology that enables industry to act now, right? Because a lot of the emissions, right, come due to process inefficiencies. So some of our products work in the steel area, steel manufacturing, in cement, in the mining industry, for example, in Chile, I think from Dr. Bernardo's home, as well as, Mexico and so on, right? And what we find is that process inefficiencies, right, and assets, that is, actual equipment, when they are not maintained well, they are a significant portion of the reasons why there are what is known as excessive greenhouse gas emissions, either directly due to the stack or scope 2 emissions because of drawing excess power wastefully from the grids, the electricity grid, right? And even if you replace those grids with solar and wind, if you have inefficient processes and inefficient assets in your industry, well, they're going to use the solar and wind assets also inefficiently. It doesn't help, right? So that's why we're developing these technologies to focus on the now, on the equipment that exists now, to reduce that emission curve now, not by buying offsets for somebody to plant trees that will eventually grow in 10 years from now, right? So that's what we do. Now, if I move forward, what do we do in these technologies is we use, cutting edge technology, not for the sake of using it, right? Now, data, as we know, plays an integral part in our ability to step away from our human biases, right? And the ability to process and correlate data so that it gives us deeper insights. We are seeing that in the medical field, right? COVID is a perfect example of that with respect to vaccine research. You're seeing that in healthcare, where radiograms, mammograms, etc., scans are now being scanned by machines, which are able to derive deeper insights and detect problems earlier. We're taking the same analogy. What we are doing is called industrial IoT, where we are measuring using sensors, how are machines behaving today? How are different assets behaving today? How is the process defined today in steel manufacturing, for example, right? How is the raw material being processed? How much of coke and coal is being brought into the blast furnace to produce steel, right? And we have made models using this data. That is the power of machine learning and AI, right? And then we have been able to derive deep insights and make the tweaks necessary for these manufacturing industries in real time, right? To control the quality of their throughput as well as to cut down their emissions. So we have sensors that measure suspended particulate matter or carbon dioxide or methane emissions from a stack. And then we work together with these industries to help them monitor this and then control that emission footprint, right? And while they maintain business throughput. No business can shut down, right? Because you'll have social unrest with people unemployed. So we are trying to address this problem of get the business running, but flatten that curve as much as we can. I'm not going to spend time on this. I mean, being a techie, there's always a software architecture diagram. But what I want you to just take away from this is that, look, we are developing solutions that integrate industries and sensors on one side, bring it into our technologies, which resides in public clouds in an efficient manner on the right-hand side, right? Process the data, right? In a closed loop system, give industries recommendations in real time. These are the 5 knobs you need to control now to control the emission profile, right? And we work in a variety of ways. We also use satellite monitoring, not just to report emissions, but to incorporate the data in and augment our intelligence in order to give better recommendations to industry to control the emission profile now, not 5 years down the road, not 2 years down the road. We are talking about 1 month, 2 months from now, once we deploy and are in production, right? And using this, we can now correlate, where the emissions are, where are your process inefficiencies, where are your asset inefficiencies, and point them out to you so that you have options. You can allow us to recommend values so that you can fine tune them right now, improve your asset reliability, reduce your emission profile. And these are, few of the things that we do. Happy to, engage with any one of you, or if you'd like, to recommend us to anyone to talk more in detail of what we do. And this is how we are focused on SDGs 9 and 12, on responsible production, right? We want companies to produce, but produce responsibly, reduce wastage, right? Don't have too much redundancy, all of which take so much of resources, apart from emissions, right? And of course, use technology to innovate in the industrial space. So this is what we are really focused on, right? And we are on this journey of set of 20, 30 passionate people, engineers who come, who are completely passionate about the environment and sustainability, right? Who practice it in their daily lives at their homes and communities, who have banded together as brothers and sisters working using technology to address these problems. And with that, hopefully, right, we also participate and provide constructive engagement as part of climate action, and have this wonderful handshake between humanity and nature. Otherwise, what's the point? I mean, that's why we're here, right? So we're trying to help in our own small way to bridge this gap and get them to handshake again in a meaningful way. So with this, I will stop, and I thank the organizers for the opportunity to share this information, and I look forward to the other presenters to hear all their wonderful insights. So thank you so much. Sagarika, back to you.
Thanks so much, Dr. Subramaniam. Really good insights. Preventive